This is a paper 2 question, and this is a mixture of different topics around statistics. So the first part is it tells us that Aidan works at the Woodcraft, and it's a company that makes wooden letters. He wants to predict the demand for letters, and he thinks that the letters earlier in the alphabet are more popular than those at the end. So they're trying to find out in the year that he was born, which is the most popular name, in the hope of trying to work that out. So there's the popularity of each of the names and then the position that it is in the alphabet. So A is the first one in the alphabet. The second one in the alphabet is the name beginning with C. The third one is the name beginning with E, and so on. And they've already ranked the two pieces of data. So we now need to calculate the Spearman's rank correlation coefficient for the data. Since it's already ranked, the first thing that we need to do is to type these pieces of information into a calculator. So we're going to go into statistics and then into data. If you have data in there, then you can just clear that out. And we're just going to type this data in. So the first one is just in order. And the second one, we're just typing in the numbers that we see in our list. And there we go. So we're now going to go into statistics, calculations, and linear regression. And we can see there that the regression, or the R value, is 0.67 and then 27. Since we know that we need to write it as 3 significant figures, the answer is 0.673. So the first one there is 0.673, and it asks us to interpret the value based on this table. So if it's 0.67, that's in this section here, which we would say is strong correlation. So strong correlation. Then part B, which is on the next page. So the company, this Woodcraft Wonders, makes the letter N, and it's a rectangular prism, or a cube, or cuboid even, with a depth of 4. And then they've cut out these 2 triangles to make this N shape. Okay, so in total it kind of looks like this. We're told that both of these are identical, and we need to find the area of the front surface area of the N. So essentially we're asked to find the area of this shaded section. So to do that, we need to try and work out the size of the full measurement, which would be 13 times 14. So the full measurement here is 13 times 14, and you can type that into your calculator, and we find that that's 182. So that's the full rectangle. And then we're cutting out these kind of triangular sections. So we have one here that's being cut out, and then we have a second one, and it's an identical shape at the top here. So if we just look at one of these, we can see that the triangle section is a height of 7. So if we just look at that triangle, it's a height of 7. Now if the whole distance here is 13, and this is 4 and 4, this is 8 in total. That means that the middle piece here is therefore 5. So the area of that triangle is 7 times 5 divided by 2, which is 17.5. So now we know that the area of the shaded part there is 182, which is the full rectangle, minus 2 lots of 17.5, which are my 2 triangles. And that gives me a total of 147 centimeters squared. Part C is then to calculate the volume of the finished letter. So the volume of any prism is the area multiplied by how far back it goes. So the answer here is just 147 times by 4, which is the depth, and that is 588 centimeters cubed. And then moving on, we can go to part D. So part D says that there are two machines that make the letter, machine A and machine B, and they are wondering whether the machines are different and creating different weights to our letters. Okay, so yeah, we've got our pieces of information here. They assume that it's normally distributed and they're going to perform a t-test of a 5% significance level. So for the first part there, we need to write down the null and the alternate hypothesis. So the null hypothesis is going to be that the mean from machine A is equal to the mean from machine B. You can also write that out in full, and you can say that the weights, or the mean weights, sorry. So the mean weights of machine A is equal to the mean weights of machine B. And you don't have to write that out in words. You can write it out either in words or in symbols. It's really great if you can do both, because then that covers your back. So that's the null hypothesis. And then the alternate hypothesis, it says that we're testing to see if they're different. So that means that the mean weights of machine A are not equal to the machine B weights. So if you were to then write that out in full, that would be the mean weights of machine A are not equal to the mean weights of machine B. And then part 2 is to find the p-value for the test. So we're going to go into the statistics and edit, and this time we're going to write down all of those measurements again. So 350, 342, 361. So all we're doing is writing out each of the measurements that we were given. 364, and then we have 338, 343, 332, 358, 349, 332 and 324, and we need to find the p-value. So it's a statistics test, and we want a 2-sample t-test, option 4. We have the first list in list 1, second list in list 2, and we want not equal to. Make sure that you have pulled yes. It should always be yes. And we can see there that our p-value is 0.119 to 3 significant figures. So there's the p-value, 0.119. Or we can write that as 11.9%, and either of those are fine. And then for part 3, it asks us to write down the conclusion of the test. So since the p-value is 11.9%, but the significance level is 5%, the p-value is larger than the significance level. And when the p-value is larger, we're saying that the probability of accepting the null hypothesis is above what we would expect, so it's good. And therefore we accept H0. So we're accepting H0 and assuming that the null hypothesis is true, that the machines create the same weights, so there's no difference between the two machines. In terms of marking, the first part of the question is actually 4 marks, so 2 of them are for correctly writing down this answer, with 1 of them also being attributed to rounding. And then there is a fourth mark for correctly reading the table, that it was strong correlation. The next part of the question, there was 1 mark for correctly working out the area of the triangle. There was a method mark for working out that you needed to subtract those triangles from the overall rectangle, and then there is an answer mark there as well. For part C, it was 1 mark, and it was just for timesing it by 4. If you had times your answer rather than 147, then you would still get that mark. For part D, there is 1 mark for each of the hypotheses. There are 2 marks for substituting in and finding the p-value, and then there is a reasoning and an answer mark there at the end, and you needed to get both of those correct. You can't get the answer without the correct reason, and you need the correct reason to get the answer.